Hi, and welcome to another episode of Technician's Toolbox. Today's case study is on a 2008 F150 pickup truck with a 5.4-liter engine. The truck was driven into the shop by the customer, and he's complaining of a check engine lights on, and the engine idles rough, it lacks power, and he also informs us that it's had new timing chains and gears. He also tells us that the VCT solenoid has been replaced. He also informs us that the truck ran fine after these repairs were made, and all of a sudden just started running bad. Technician grabs a scan tool, runs out to the truck, and retrieves the trouble code. He's got a P0012 and a P0022, intake camshaft position timing over retarded bank 1 and bank 2. Description of this code is that the powertrain control module monitors the variable camshaft timing position for over-retarded camshaft timing. Test fails when the camshaft timing exceeds a maximum calibrated value or remains in a retarded position. Some of the possible causes for this are the camshaft timing incorrectly set, continuous oil flow to the VCT piston chamber, VCT solenoid valve stuck open, or camshaft advance mechanism binding in the VCT unit itself. This worries the technician a little bit, seeing that the customer informed us that most of these things have been replaced. Technician decides to bring the vehicle in for further inspection. As he drives it in, he does notice that it runs normal at this time. The technician begins his diagnosis by recording some scan data. We're going to let Jeff explain what the technician saw.
And now we're going to take a look at some scan data at idle. Let's start at the bottom very quickly, just before mark minus 6.5. You'll notice that VCT duty cycle and VTC duty cycle 2 both abruptly go from somewhere around 35% to 0. Looks like maybe closer to 50%, but they both drop immediately to 0. That is where the technician had the engine RPM up, and now he drops the throttle to idle. Notice moving upward now to the top that our VCT Advance and then VCT Advance 2 are less than 1, which is pretty close to 0, 0.06 and 0.12, so they're very, very close to 0. If we look at our VCT Advance error PID in the middle, we have error and then error 2. There's a couple things I want to point out. First of all, this particular PID displays as a histogram, so that blue bar indicates what is happening at the far right-hand edge of the capture. Same goes with the digital readouts on the IDS capture. So whatever is current is what's being displayed on the digital readouts and what's being displayed on those blue bars. And as we can see, everything's working properly right now. The blue bars are at 0 degrees. The DTC duty cycle, the duty cycle for the solenoids is at 0, meaning that the PCM is trying to advance the cams, and it is being done. Well, now let's let the car run for a while at 2,500 RPM. So at this point, at somewhere around minus 20 or so, if you take a look at the VCT duty cycle PID, that is where the engine comes from 2,500 down, back down to idle. Okay, and we can see some things happening here. Well, first of all, short-term fuel trim for bank 1 is up at 13%. Short-term fuel trim for bank 2 is at minus 13%. This caught the eye of the technicians working on the vehicle, and they got all involved in it, thinking that it was a fuel trim problem. But if you go back over toward the left side, when the engine was running at 2,500 RPM, we see that the fuel trims were not nearly as broken. They also were not opposing each other. You know, like I said, this is a typical appearance of a volumetric efficiency problem, but volumetric efficiency problems generally happen as you increase the RPM. So it could be a restricted precat, that would cause a problem like this, but not under these conditions, because the problem isn't there at 2,500, but it comes there at idle. So there's something causing a change in volumetric efficiency at idle as opposed to 2,500 RPM. Next, we look down and we see that the VCT Advance is at 0.68, where the marker is. The Advance 2 is 35.8. Also note that the VCT Advance error is 41 degrees, and that means bank 1, and the VCT advanced error is minus 35 degrees. So we have something significantly wrong. At the time that we have these offsets in VCT error, we have a duty cycle of 0 for the solenoid that controls, and the last solenoid is missing. We can put that many PIDs on the screen, but they're both at 0. So what is going on? But the one thing that makes this pretty tricky is that Ford uses cam 2 for its cam crank synchronization. Since cam 2 is the cam that is in error by 35 degrees, the PCM is incorrectly marking where the cams are supposed to be and displaying an error for cam 1 as well. The cam that is not working properly at this moment is cam 2. Now later on, after letting it get hotter and hotter, both cams will end up being at retarded. The problem is that the PCM is relying on bad information where the correct position for the cam, and therefore producing an error for both cams. So now the question is, what would make a cam stick retarded, but then occasionally not do so?
This animation shows the flow of engine oil in the VCT system and how it retards or advances the camshafts. At 0% duty cycle, there is oil flow into the advance cavity and out of the retard cavity. This is normal oil flow with no camshaft movement. At 35% duty cycle, the oil flow is somewhat restricted, allowing some advance of the camshaft. At 50% duty cycle, the oil passages are blocked. This holds the cam at whatever position it was last in. At 75% duty cycle, we flow out of the advance cavity and into the retard cavity. At 100% duty cycle, we continue to retard the camshaft at a faster rate. Okay, we still got this truck in here. It's got trouble codes and we need to fix it. Jeff gave us an analysis of the scan data. Have you been able to draw any conclusions yet? We also learned how the VCT system advances and retards the camshaft. So as a summary, oil pressure is needed to advance and retard the cams. We agree upon that. Cams on this vehicle retard when the engine RPM increases but do not return to normal position at idle. Have you come up with a conclusion yet? Let's go back to the basics for a minute. What makes this camshaft function? Remember, oil pressure is needed to advance and retard the cam. Technician gets out his oil pressure gauge and goes back to the basics. He measures 7 psi oil pressure at idle, way below what the specs should be. The fix for this vehicle was a new oil pump. Remember, just because this vehicle has all this high-tech gadgetry, don't forget the basics. Thanks for watching Technician's Toolbox. See you next week.